Here we're looking at the 2020 Chemistry 1, Paper 1. Let's just have a quick review. Which isotopic half-life is best suited for use as a tracer in medicine? This would be something around 15 hours. We want the tracer to last for a good while, but we don't want it to last too long within the body, that it may or may not cause different types of medical complications. Number 2, which of the following factors is important in determining the stability of an isotope? This speaks to the ratio of protons and neutrons, because these isotopes, if they're unstable, that means that they have varying ratios of protons and neutrons that will make the nucleus unstable. It's not really dependent on the electrons. For number 3, based on the data in the table above, the relative isotopic mass of lead is, so for this we're going to have sigma, right, relative isotopic mass times the abundance, right, divided by 100. You should get the value around 207.241, which B would be the best answer. Which of the following solids has a giant molecular lattice? This would be sodium dioxide. The overall valence equation for the reaction here will be C, best one here, and the oxidizing agent tends to be the one that is most likely reduced, and the one being reduced here would have been molecular iodide. Remember, if there are any issues with my answers, please be free to dispute it in the chat, and let's build a conversation around it. The ionic equation for the following reaction, for the reaction of magnesium with hydrochloric acid is stated here. The molar volume of gas at RTP is 24 dm³. The volume of the gas produced is 1.2 grams of magnesium. The volume of gas produced when 1.2 grams of magnesium reacts with hydrochloric acid at RTP is here. What I would have done is sort out a mole statement. Some persons just have the equation. What I would do is sort out a mole statement here. So if 12 grams, we're looking at 1 mole of it, right? And we're looking at the grams per mole here. We're talking about the gram here, right? In 1 mole of magnesium, there is 12 grams, right? In 1 Avogadro's number of magnesium, there's 12 grams. So if that 12 grams produces 24 dm³, what would 1.2 grams of magnesium produce? And we call that value x. And all we should do is cross multiply. We'll have x is equal to 1.2 times that 24 divided by the grams per mole, the molar mass, right, of magnesium. That is what I did to get this. My answer would be 2.4. So let's move on. 86. With this, I think I discussed this in the 2021's paper. Right. For this question, we're going to be looking at the molar ratios. Right. It should be evident that you should find the molar ratio of we should find the mass of calcium sulfate here should be around, what should give us around 0.5 moles, and water should give us generally 1. So when we divide 1.1 by 0.5, we should get 2, right? So based off of that, so the answer isn't technically 1, but it's 2. 9. Which of the following criteria should be considered when accepting scientific theories? So experiments must be replicable, data collected should be accurate and reliable, theories should show congruence between evidence and theoretical constructs. Not necessarily. 1 and 2. Deviations from ideal gas behavior generally occur under which conditions? Right. I'm gonna give you guys a second to really think of that. Which conditions do we have deviations on the ideal gas law? Just giving you a second to write in the chat real quick before I continue. Alright, so as you know, so it's supposed to generally be below temperature and high pressure. So I hope you guys got that. Alright, here we're looking for a pi bond. C would be the pi bond. Which of the following statements are true regarding the factors affecting ionization energy? So shielding will increase shielding will decrease ionization energy. Increase size of positive nuclear charge, I don't think it will decrease ionization energy. An increase in the distance, that should do it. So 1 and 3, B. Here we're looking for oxidation. This is generally a repeat question. What I tend to look for is that you know that oxidation can be defined in a number of ways, right? Such as the increase in the oxidation number, the increase in the number of oxygen on the molecule, basically, right? So looking at that, so what I see is that there's no oxygen added here, here, or here. So the answer would be C. And if you check out the numbers, you should be able to get that. Now, the second ionization energy of calcium is 1,150 kilojoules per mole, which is the following equations represents it. So we're looking at the second ionization energy, meaning that we're going from one calcium ion, right? 1 plus ion to a 2 plus ion. Therefore, B is out and D is out. And we have to know that ionization energy is endothermic, therefore C is out. So A would be our answer. 15. When magnesium metal reacts with dilute with nitric acid, 0.512 moles of hydrogen gas is produced. Right? Okay, so for this, we have temperature, pressure, R, and moles. Therefore, we're gonna use here PV is equal to nRT, right, where P is going to be the unknown. So we should be able to do that and get this value here. Remember that generally we have to take kilopascals in pascals, right? And generally the answer we get would be in meters cubed, right? But any way you really get it, the closest answer would be B. Here we're looking at number 16, so determining the overall order of this reaction. Remember, when you're looking for the order of one specific thing, we have to find where it remains constant, right? And the values relating to it changes. We're gonna see that A is gonna be remaining constant. Right, so first order reaction, how does that work? So we're saying that A is first order, right? Well, the reaction is first order with respect to the reactant A. Is that it? Does it double? Right? We're looking at the rate stays the same. So is this first order, second order, or third order? Right? So we have to really look at that. Give you guys a second to figure out that. Alright. So remember that we're looking at the concentration and the rates. Right? So based off of this, we could state, right? Or we would like to state that first order reactions, let me just get this here. So first order reactions tend to have the rate staying the same. So as the concentration hold on. I think I've made a mistake here. We have to look at where A is different and B remains the same. My bad. My bad, I can make mistakes. Alright, so here we're gonna have this being double because after a while I just figured out that wait, something's not working here. Right, so we have to look where A differs and B remains the same. So we would have this doubling, so the reaction is second order with respect to A. My bad. I hope I didn't scare anybody there. And with respect to B, right, it has to be changing and A remains constant. And with B, it is first order with respect to B, and overall order should be the reactant, well, the singular order of reactions with respect to the concentrations, right, in their sum. So that would be 3. So we're gonna get third order for this. Which of the following phrases does not define the rate of a chemical reaction? So look at the formation of product, consumption of reactant, and the change in concentration of product with respect to time. The rate of consumption of the product doesn't technically define it. Alright. John plans to measure the rate of reaction between calcium carbonate and hydrochloric acid. Which of the following setup of apparatus is most suitable for this investigation? So we know that this is a carbonate and an acid, so it will producing carbon dioxide gas. And most likely we would like to use a gas syringe. Alright. Here the buffer, I think this is a repeat question. Here we'd use the Henderson-Hasselbalch equation after we found the concentration, the molar concentration here. Right, so after we find the molar concentration of sodium benzoate, right, we already have the concentration here, we have the Ka, so we can find the pKa. So remember that in the Henderson-Hasselbalch equation, pH is equal to the pKa plus the log of the salt ion concentration over the acid concentration, right? And we know that pKa, P notation speaks to the fact that P is the same as a negative log base 10, right? So we're logging the Ka. We should be able to get a suitable answer around 3.9. Right, the solubility product of barium sulfate at standard temperature is 1 times 10 to negative, well, 10 moles squared per dm negative 6. The number of moles of barium sulfate that will dissolve in 1 dm cube. We're just going to divide that. Alright, we're just going to be dividing that, and we should get around this. So let me see. Let me remind myself what we divide by here. Alright, give me one moment. I hope this isn't too loud. Alright, now we divide by that. Alright, so we're going to divide by, so the solubility product generally, here, the number of that which would be dissolved. So we're going to be dividing it by 2, right, to get it back to mole per dm cube. So now it's mole per dm cube squared. So what we're gonna do here, oh, it's squared, my bad. So you're gonna have 1 times 10 to the negative 10, right, and we're going to square root it. 1 times, give me a moment, my calculator is giving me trust issues. 1 times 10 to the power of negative 10 should give us, yeah, so we're going to square root this to get back our original value, right, and that would be C. 21, what effect does a catalyst have on a chemical reaction, right? So the catalyst is consumed, no. The rate of reaction will be decreased, no. The rate of reaction will be doubled, not necessarily. And A, activation energy will be lowered. Compound P, Q, and R equilibrium, we're looking at this. So remember that Kc is going to be our products, over or reactants, right? So our product here would be, well, it's going to be R squared, concentration of R squared. Remember, it's brought to the power of their stoichiometric coefficients. We're going to have P squared, and then we're going to have Q. All right, so I hope we have that. I'm going to erase and do the units of K now. Well, I can just do it over here. So let's do the units of K. Let's translate the units. Right, so remember the units is always mole per dm cube. So we're gonna end up with mole squared dm -6 at the top because we're squaring this. Then we're gonna end up with mole squared dm -6 down here times, because this is squared, so times regular mole per dm cube. Right, so we're going to end up canceling these, right, and this is going to be left, right? So, well, let's not do that. I think there's going to be an issue that arises if we do that. Let's just do everything, right? So we're going to times the bottom, so we're going to end up with mole squared dm -6, right? We're going to times the bottom, we're going to get mole cube. Remember laws of indices, we add the indexes, cube dm to the -9th. So when this cancels out, we're gonna get moving to the top, mole -1, right? Because it's going to be mole 1 on mole regular here, right? So I have to put it to -1, and here we're going to have mole -3. When this is brought to the top, we're going to get dm cube. So it just switched around here, so we have the mole there, dm here, right? Now the expression for solubility product KSP lead iodide. So lead is a 2+ ion, and iodine is usually negative, right? Just negative by itself because halogen, right? So we're gonna see here that it's gonna be lead I2 generally, right? When this dissociates, we're gonna get lead 2+ ions plus 2 iodine ions, and if we're gonna write that as KSP, we're gonna get lead 2+ plus I minus brought to the power of 2, right? I think so. I'm not remembering if a 2 should be in here, but you guys can tell me in the comments whether or not 2 should be there. So we're gonna have P there. Not quite remembering if a 2 should be there, I'm not sure. Alright, so 24, which of the following statements does not refer to the system in dynamic equilibrium? Reaction is reversible. That is true. The amounts of all the species in the system remain constant. Not sure about that. The concentrations of all reactants and products are equal. The rate of the foreign reaction is equal to the, okay, that's true. So C and B are giving issues. So the amount of all the species don't remain constant because they're continually being changed, right, at the microscopic level. But at the macroscopic level, it seems that they remain constant, but you have a constant push and flow, right? There's never the exact same amount, but the concentrations appear to be equal. So I would believe that B is the answer. If you think that there's another answer here, just drop a comment. Alright, which of the following conditions will cause an increase in the cell potential here? So cell potential is affected by concentration, right? So I don't think that this would be the answer. Decrease in the concentration of ions. Okay, so we have A, B, C. Alright, where do electrons move within an electrode? chemical cell. Right, we're not looking at the cells from CSEC, that's different. We're looking at the galvanic cell, right? So electrons in a voltaic or galvanic cell generally will move from the anode, right, to the cathode. So electrons are moving in this direction, right? So if we increase the amount of right, so let's here. If we increase the concentration of, decrease the concentration of copper ions, will that increase the cell potential? Let's see. Decreasing concentration of ions and increasing concentration of copper 2 ions. I believe that this would be the best answer here, but I think that this is a bit off. So if there's an issue with this, don't be afraid to just leave a comment in the chat and discuss it. Alright, which of the following pairs of substances would make a good buffer? These are strong acids. Alright, this would make a good buffer. C. During a chemical reaction, disproportionation is said to occur to substance. Both oxidizes and reduce. It's both oxidizing and reducing agent, right? So, what is the potential for a cell with the following reaction? Alright, so we're looking at this. So we're looking at this, right? So we're gonna have lead losing, well, zinc, my bad, losing electrons, right? And the oil rig dictate that oxidation is loss and reduction is gain, right? Where are electrons lost on the cell? It's at the anode, right? And we're looking at how we calculate EMF generally, right? So the EMF or the E naught of a cell, what is it, right? So if the E naught of a cell, give me a moment, let me write it down, is equal to cathode minus anode, or is it anode minus cathode? How do you calculate the E naught of a cell, right? Before I do this, I would like you to recall how you calculate it real quick. Just see if you can recall it. Right. So calculating the EMF, well, our cell would be cathode minus anode, right? So if zinc is the cathode, well, if zinc is the anode, right, then we're gonna have, well, on the electrochemical series, is zinc higher than bromine, right? So we could talk about that as well. In the electrochemical series, it is zinc higher than bromine, right? So I would probably believe that bromine may be higher than zinc, right? Because it is, because the zinc is usually the 0.76, right? Negative 0.76, and then the bromine would be the negative, well, it'd be more of a positive actually, but okay. Yeah, so it would be more of a positive. But let's look at this, right? So we're seeing it's going to be cathode minus anode, and the anode is -6. So, well, it's negative, right? The cathode, well, the cathode would generally be positive in this case. So I would believe that the best answer probably would be A. Alright, but give me one moment, let me think of what bromine would be. Alright, so if we look at a bromine half cell, what would be that? Okay, I would believe that these may be both. The bromine may be positive and the zinc may be negative, right? But I want you guys to comment on that and see if there's an issue here. Remember, if we find an issue with something on the paper, right, just tell me and let me know. Right, give me an explanation and I'll see what I can do with the question and post the answer, right, the correct answer in the chat if I put something wrong. Right, so the value of Kc for the equilibrium here. All right, so we were arguing that since everything is halved, we're just going to get the 860 divided by 2. 860 divided by 2. Oh, sorry, my calculator turned off. 860 divided by 2, we should get around 430. Right, oh, that's really how math works. Right, so we're looking at that. Here now the standard electrode potential of tin, right? Is that the EMF is here, right? So looking at what is unable to reduce tin. So if it has a more positive value, it's going to be unable to reduce tin, right? So these are all more negative than it. So D should be fine. Which of the following statements about bromine is correct? It has a red brown color, right? It is denser than chlorine and it is it's more of a volatile liquid, so I won't say it's just a gas at room temperature. Technically it is. Technically it's between both. We most likely describe it as liquids. Which of the following oxides of element period 3 correctly match with acid base character? Now most of them are amphoteric in nature. So this question, I believe that sodium oxide would be basic and phosphorus oxide would be acidic. It depends whether or not you want this answer to say amphoteric or basic. But since I would know that amphoteric means that you show both acid and base character, right? I'm not sure whether or not you would choose D. But if you're saying that it has to be amphoteric and not acidic or basic for aluminum oxide, then it would be C. So tell me what you think for that answer, please, down in the comment section. 33. Which of the following elements react very slowly with cold water and burns with a bright white flame? This would be magnesium. Calcium carbonate decomposes at lower temperatures than barium carbonate. This is because calcium oxide is less stable than barium oxide, larger than calcium ion is larger than tended into formation of calcium oxide is less negative. Acid energy of calcium oxide is larger than the barium oxide. Right, so what would be the best thing here? Right, so the smaller, the more distorted. The smaller the ion, the more distorted the electron clouds on the carbonates. Right, so I believe that calcium probably would be smaller than barium. Let me think about that real quick. No, it won't be larger, so I don't think it would be larger. The standard formation, does that have to do with the decomposition of the carbonate? Probably slightly, right? But most definitely the simplest answer to go with here is that calcium oxide is less stable than barium oxide. Right, but if you believe it's something else, please tell me. Right, and I might do something on the paper that I would require you guys to look at, right, specifically, because I don't want to just give away answers. I want you guys to think. So if you notice that something is off, say something about it. Give me 1 moment. I'll be back. So we're continuing a chemistry unit 1 2022 paper 1. Which of the following properties belong to group 2 elements? So we know that they have high melting points but low densities, right? The insolubilities of group 2 sulfates make them very useful in diagnostic medicine because they appear opaque on x-rays. Which sulfate is the most commonly used in X-ray? This would be barium sulfate. 37. Silicon carbide has a structure similar to that of diamond. What are the advantages derived from using silicon carbide ceramics when compared with steel? So silicon carbide is most resilient to oxidation. So I have melting point. Let me see. Is less likely to deform under compression. Alright, so we're seeing that it's a little bit more resistant to oxidation than steel itself. Silicon carbide too. Okay, should be fine there. Silicon carbide has a higher melting point than steel. Silicon carbide should be fine. Not sure if it has a high melting point though, because it is within the group 4, peer 4, or is it peer 3? Peer 3, group 4, right? We're looking at that it would have a relatively higher melting point than the others, so it should be fine. Silicon carbide is likely to deform under compression. Yes, it's not a metal, so it's not that malleable. So I believe that D is the better answer here. You tell me. Right, which of the following transition elements are of unpaired electrons? Remember, we are dealing with the 2 C's, right? So the 2 C's. So C here. Chromium. The sharp increase from copper to zinc is caused by, where's copper? Copper to zinc. We're seeing that the ionization energy increases sharply, right? And we're saying that this is caused by 4s orbitals only, for the orbitals only. Well, it's caused by filled d orbitals only, s and d orbitals, right? Or the 4s orbitals and a half filled to 4d orbitals, right? So I don't think it reaches 4d as yet. Right, don't think it would constitute that because zinc would already have a full. So I think it would be the orbitals. Here now, which of the following oxides? Oxide of silicon. Silicon should be B here, giant covalent. Which should be oxide of sulfur. Sulfur should be A. Alright. Here lead, we know that lead would form the golden precipitate here. D. Zinc is soluble in excess ammonia, and lead or aluminium should give a white precipitate. So B. Alright, and here chlorine would be stronger oxidizing agent, right? Because iodine is not stronger. We know the trends, right? Both of them have oxidizing characteristics, yes, and they don't show both the same oxidizing power, so A would be the best answer here. So that's it for the 2020 Chemistry Unit 1 Paper 1. Right, thanks for viewing.